Limits at infinity involving exponential function. The first function is e times e to the x plus 4 divided by 2 times e to the x minus 5. If you just plug in infinity, you will get an infinity over infinity, which is undefined. Let's write this out. So we have 3 times e to the infinity and then plus 4, which is infinity, right? And then 2 e to the infinity minus 5. So this will be a very large number plus 4, that is infinity. And then e to the infinity is infinity minus 5. So that is infinity. When you have infinity over infinity, I just say undefined. Actually, a more appropriate word to describe that is cannot be determined. So infinity over infinity and 0 over 0, they are actually indeterminate form. So this, I would just say this cannot be determined. So cannot be determined. So when you encounter infinity over infinity or 0 over 0, you have to do something else. You cannot just plug in and then give me an answer. And one more thing, infinity over infinity is not equal to 1. Again, infinity over infinity is not equal to 1 because you do not know which infinity is bigger, or you don't even know if they are identical, right? It is just a very large number. It is not an exact value. Okay, so what do we do? Take a look. This is x approaches to infinity, right? Then we have to take a look at the denominator. So which term has the highest exponent? Like which term is the biggest? Which term is the biggest in the denominator? The term that is bigger than everybody else. That is the e to the x, right? Do we care about what's the biggest in the numerator? No. We don't look at the numerator at all. Okay? Again, we do not look at the numerator at all. Everything depends on the denominator. Pick the person that is the biggest, which is e to the x, and then we have to divide each term by that, which is e to the x. So we have to draw this and then multiply 1 over e to the x, 1 over e to the x. That means you are dividing each term by e to the x. All right, so let's continue. So that is equals to, always start with equal, and then you write a limit, and then you have 3e to the x divided by e to the x plus 4 divided by e to the x, and then divided by 2e to the x divided by e to the x minus 5 divided by e to the x, and then you simplify that, of course. Then you have limit as x approaches to infinity. You have a 3, and then 4e to the x, the bottom, you have a 2 minus 5e to the x. So once x approaches to infinity, all the little fractions become 0 because 4 or 5 divided by infinity is just equals to 0. So once x goes to infinity, we have 3 plus 4 divided by infinity, and then 2 minus 5 divided by infinity. E to the infinity is infinity. You can look at the graph, or you can think about that as 2.7 or 2.71 raised to a very large exponent. So that is infinity. And then we have 3 plus 0 divided by 2 minus 0. So that is equals to 3 over 2. So that means if you graph this function, y equals to 3 over 2 is a horizontal asymptote. Okay, so y equals to 3 over 2 is a horizontal asymptote. So there is a what if. So what if we have x approaches to negative infinity? Do we reach to the same conclusion? Right? As x, what happened as x approaches to infinity? So what happened? Right here. Actually, we can switch to another color, and then just this is like another problem. So negative infinity, and then we have 3e to the x plus 4 divided by 2e to the x minus 5. Are we safe to just plug in? So this one, let's just try to plug in. If we just plug in, we have 3e to the negative infinity plus 4, and then divided by 2e to the negative infinity minus 5. That looks good to me, because this is a 3 divided by e to the infinity plus 4, and then over e2, and then e to the infinity minus 5. That's how the negative exponent works, right? Then we have 0, right? 3 divided by a very large number plus 4, and then 2 divided by a very large number minus 5. 0 plus 4, 0 minus 5, we have a 4 divided by 5. So that means as x approaches to negative infinity, we have y equals to 4 over 5 as the horizontal asymptote. Right, so this function has two horizontal asymptotes, one at y equals to 3 over 2 that affects the right end behavior. You look all the way to the right, and then the 4 over negative 5, so 4 over negative 5, so is the horizontal asymptote as you look all the way to the left. Okay, so let's take a look at the yellow one. We have 3 to the negative x minus 8, 2 to the negative x plus pi. Are we safe to do a plug-in? Let's try. So we have limit, or actually we don't need to write the limit anymore. So we have 3 and then negative infinity, right? Minus 8 and then 2 negative infinity plus pi. Then we have 3, not 3. Then we have 1 divided by 3 to the infinity minus 8 and then 1 over 2 infinity minus plus pi. So all the fractions becomes a 0, right? So all the fractions becomes a 0. And then what do we have? We have 0 minus 8 and then we have a 0 plus pi. So therefore negative 8 over pi. So if you graph this, we have y equals to negative 8 over pi as the horizontal asymptote. All right. Can we do some what if? For the first problem, for the red one, we can do a what if. So let's try this. How about let's pick another color. Let's pick a orange. So limit as x approaches to infinity. Okay. How about this? 3 times e to the negative x plus 4 divided by, and then 2 times e to the negative x minus 5. This one it is safe to do a plug-in? Absolutely yes. So this is a 3 e to the negative infinity plus 4 and then 2e negative infinity minus 5. So this will be a 3e infinity, right? Plus 4 and then a 2e infinity minus 5. So fractions becomes a 0, then you have a 4 over 5. So for this function, y equals to negative 4 over 5, this is my horizontal asymptote. All right. How about x approaches to negative infinity? So how about x approaches to negative infinity? So let's try this. So what happened as x approaches to negative infinity? I want to use a different color for that. So let's use a green. So limit as x approaches to negative infinity, 3e to the negative x, we use the same function, right? And then 2e to the negative x minus 5. So if we force to plug in, then we have 3e to the negative infinity, right? And then 2e negative infinity. So this is a plus 4, this is a minus 5. We have a problem. So we have this plus 4 and then this minus 5, then you have an infinity over infinity. So then you have an infinity over infinity. This cannot be determined. So what happened in this scenario? So in this scenario, then you will have to then you have to do the algebra. So this one, then you will have to take a look at the term, the biggest term, which is e to the negative x. So this one, let's go ahead and then do the algebra. So we are going to multiply the top and bottom by 1 over e to the negative x, 1 over e to the negative x. And then what will happen? So we have a limit as x approaches to negative infinity, 3e negative x e to the negative x plus 4e negative x, and then 2e negative x e to the negative x minus 5 divided by that. So we have negative infinities, and this is a 3, and then this is a 2, so we have a plus. Okay, so this one we can bring the e up, so 4e to the x minus 5e to the x. So when you plug in the infinity, then you have a 3 plus e4 times e to the, so that will be a negative infinity. So with that becomes a 0. And then this is a 2 minus 5 e to the negative infinity. So you bring it down, right? Like that. And then 5e to the infinity, they are both 0. Then this is a 3 over 2. Alright, so that's the end of this video. If you like it, you think this is helpful, give me a like, share, and subscribe. And I will catch you all in the next one. Signing out.